What we're going to look at next is a formula that you can use to solve quadratic equations, even when it's something you can't factor. If it's got weird decimals in it, or something that you might be able to factor, but you just don't want to spend the time on it, this formula is going to be extremely useful for the kinds of problems you run into in the future. We're going to look at solving equations like this, where there's a number times x squared plus another number times x plus a constant term equals 0. So just like when we were solving by factoring, we would want to get things equal to 0 first. Once you've done that, you're not going to have to follow all the way through these complicated steps. If you want to, you can read through these steps on your own later to see where this formula comes from. But the key is this bit at the end. This is going to be what you want to remember. That you can find the solutions to this equation, ax squared plus bx plus c equals 0, using what we call in algebra the quadratic formula, which says you take the opposite of b plus or minus the square root of b squared minus 4ac, all that over 2a. What's going to be great about this one is it'll solve any quadratic equation. Any equation where your highest power is x squared, you can use this to solve it. Even if it's something that you wouldn't be able to factor, this will always give you the answers if there are answers. So let's take a look at as an example at our equation 3x squared plus 16x plus 5 equals 0. In this case, a is the coefficient of x squared, which would be 3. B is the coefficient of x, which is 16. And c is the constant that's added at the end, which is 5. So we're going to use our quadratic formula and plug those in the places of a, b, and c. Our formula starts off with a negative b. So the top of your fraction, you always start with the opposite of b. Here, instead of 16, we would have negative 16. Then you always have a plus or minus, a square root. The first thing under the square root is b squared. So in this case, we have 16 squared. Then you're always going to have a minus 4 multiplied by two numbers. In this case, a and c are 3 and 5. So we have minus 4 times 3 times 5. And then on the bottom of the fraction, we have 2 times a, which in this case is 2 times 3. So one way of looking at this is when you're setting up the quadratic formula, we're going to simplify that and finish it here in a moment. It's always going to look like this. A number plus or minus a number squared minus 4 times one number times another number divided by 2 times a number. And then you're always going to be just plugging in numbers in those 5 spots. You plug in the opposite of b at the beginning. I guess I could put a minus sign right there. And then b squared minus 4ac over 2a. My dog's not very happy. She really doesn't want me to talk about the quadratic formula, but I'm going to keep doing it because that's what I want to do. All right. So having set up that problem, a lot of students set it up correctly, but then they make mistakes trying to do too much all at once. So let's take a look at this and do it just a little bit at a time. We're going to leave that negative 16 on top alone for right now. There's not really anything we can do with that yet. Then we put plus or minus square root. We're going to do the squaring and multiplying parts. 16 squared is 256. Then negative 4 times 3 times 5 is minus 60. On the bottom, 2 times 3 is 6. And that's it. We leave it like that. The next thing we do is subtract the numbers under the square root and leave everything else alone. So 256 minus 60 is 196. Like that. Next, we simplify the square root if we can. In this case, the square root of 196 is 14. So we have negative 16 plus or minus 14 over 6. So to finish the problem, because it's a plus or minus there, it means it could be a plus or it could be a minus. So we need to do both. We need to do negative 16 plus 14 divided by 6 and negative 16 minus 14 divided by 6. The top one, negative 16 plus 14, is negative 2. And negative 2 over 6, if we reduce it, we get negative 1/3. The bottom one, negative 16 minus 14, is negative 30. Negative 30 divided by 6, we get negative 5. So that equation has two solutions, negative 1/3 and negative 5. Now, the quadratic formula can seem pretty complicated and a little bit intimidating the first couple of times you go through it. What you'll get used to is that the steps are the exact same steps every time. Once you can do the steps on one of these problems, you can do the steps on any of these problems. Let's try another one here. 2x squared plus 9x plus 10 equals 0. I like to start just by writing out what A, B, and C are. Here, A is 2, B is 9, C is 10. And we're going to start, just like we always do with quadratic formula problems. Sometimes I'll even just write out all of this. And then I'll just go through and fill in the blank spots with A, B, C's. So on this problem, A is 2. So everywhere there's an A in the quadratic formula, I put in a 2. B is 9, so everywhere there's a B in the quadratic formula, I put in a 9. And C is 10, so that one spot in the formula where there's a C, I put in a 10. Every problem is set up that way. Now it's just a matter of following the exact same steps to simplify it. So this is one of those things where getting used to the setup takes a while, but once you do get used to it, the exact steps are, you have to learn it once and then you can do any problem. 9 squared is 81. Negative 4 times 2 times 10 is minus 80. On the bottom of this fraction, 2 times 2 is 4. Next, we simplify the stuff under the square root. We have negative 9 plus or minus 81 minus 80 is just 1. And then the square root of 1 is 1. So we have negative 9 plus or minus 1 over 4. And because it's a plus or minus, we have to work it out twice. Once with the plus and once with the minus. So we have negative 9 plus 1 over 4 and negative 9 minus 1 over 4. Negative 9 plus 1 is negative 8. Negative 8 divided by 4 is negative 2. Negative 9 minus 1 is negative 10. Negative 10 fourths, we can reduce it by dividing both parts by 2. We would get negative 5 halves. So our two solutions to that equation are negative 2 and negative 5 halves.